Okay, so this first one concerns the reaction of glucose with oxygen, also known as the process that happens in your body to create energy. Maar ek verwag nie van julle om byvoorbeeld die formule van glikose te ken nie. Okay, so let's start nice and simple. First question, balance this equation. Okay, so die maklike plek om te begin is by die koolstowwe. So sien julle hier 6 voor die tyd en net 1 na die tyd. So that has to change to a 6. And then, nee, ek wil met die swart pen skryf. Okay, en dan as ons kyk na die water, sal jy sien hier's 12 en hier's net 2, so hy is ook 'n 6. And then you normally leave your oxygens for last because they're the easiest to balance afterwards. So there's 12. So that's also a 6. No? Yeah. Because you have to take those 6 into account as well. Okay, good. Easy enough. For the second one, I'm going to ask you, determine the mass of O2 needed to react (25 grams of the glucose). Okay, so as ek vir jou sê, daar gaan 25 gram van die glikose reageer, bereken vir my watter massa van die glikose het ons nodig om dan te reageer. Okay, so when in doubt, take it to mole. Because remember the relationship of glucose to oxygen, we have determined to be 1 to 6. But you can't say 25 grams of this one and then times it with 6. That relationship is for moles. So you need to calculate the amount of moles of glucose first, and then you can use that relationship. If you guys don't have a periodic table nearby, carbon is 12, hydrogen is 1, oxygen is 16. Sandra, you mustn't just copy, you must calculate yourself. Okay, so we calculate the molar mass of glucose by using the values on our periodic table. And then from there we say, okay, if we have 25 grams of glucose, we can use this formula to calculate how many moles of glucose we have. Yeah, okay. And remember, we don't want to round off until we get to our final answer. So as jy hom gaan afrond, rond hom af soos 4 of 5 of 6 desimale plekke sodat jy weet dit gaan nie jou finale antwoord beïnvloed nie. Okay. And now we can use this relationship. Okay, so ek weet nie hierdie een is nou lekker maklik. Stem julle saam om die aantal mol van die suurstof te kry, gaan ons nou net sê dis daai 0,138 repeterend mol met 6. Because the relationship is the easy one to work with. It's 1 to 6. Okay? But I never know if I showed this to you guys or only to my class. Let's say you had a more complicated relationship, like 2 to 9. Remember, you can always use, let's say you calculated you have 1,342 of that one, and you need to calculate that one, then you can use cross multiplication. Okay? So then 9 times that is equal to 2x, and then you can solve for x. But this one, we don't mark how you got to the answer. So this is only a useful tool that you can use if you are struggling, like if it's a more complicated relationship that you're working with. But this one is fairly easy. So it's just that times 6. And then you get 0,83 repetitive mole. Similar. Because the basic relationship that I'm working with is 1 to 6. So that's why I times it by 6. Almal seker waar ek dit gekry het. Vir elke 1 mol glikose wat reageer, moet daar 6 mol suurstof teenwoordig wees om ook te reageer. So for every 1 mole of glucose that reacts, I need 6 moles of oxygen present to react, and I get it from there. Always from your balanced equation, because it's 1 to 6. 1 mole of glucose, 6 moles of oxygen. Is julle wakker? Yo! Dit. Anyway, and now if we have that, we can calculate the mass of the glucose. Why? Because we have this one. So we're going to write it like this from the beginning. Don't believe everything you see. Don't just copy mine. It shouldn't be 180 because I'm calculating the mass of the oxygen, not of the glucose anymore. To make it easier for yourself, use little subscripts. So you're working with mass of oxygen. This one is the molar mass of the glucose. Clearly mark your work to make sure you don't make silly errors like that, because I promise you, they do get made often. Where I get the 32, I just said 16 times 2 because oxygen is 16. En ek gaan nou eers om afrond. So as jy joune heeltyd gewerk het met so 5 of so, dan gaan jy in elk geval by dieselfde antwoord uitkom. Okay, so that was number 2. Number 3, I ask you calculate the volume of CO2 formed. If they don't say anything, remember, then you assume it's at standard temperature and pressure. As hulle sê dit is by 'n ander temperatuur of 'n ander druk, dan moet hulle vir jou 'n nuwe konstante gee. So when we're working at standard temperature and pressure, the constant will be 22,4.
Ma'am, by the previous answer, the calculator says 26,56.
Did you round off in between? Yeah.
Ma'am, I wrote the 0,83 though. Times the 32.
0,83 repetitive. Yes. That's why I said be careful to round off before you get to your final answer. Okay, and it's one of those weird things, like sometimes they don't mark it that strict, but sometimes they do. So don't risk it. Okay, goed. What I was busy saying is when it is at standard temperature and pressure, that is when the volume of 1 mole of gas is 22,4 cubic decimeters. Kom ons sê dit was nie so nie, ons gaan nou werk met 22,4, maar kom ons sê hulle sê vir jou hierdie reaksie vind plaas at room temperature. Remember, standard temperature and pressure means it's at 0. Room temperature normally we regard to be around 25 degrees. Then they have to tell you the new constant that you are working with is, I think this one is actually 25 cubic decimeters per mole. So then this will replace that constant. But then they have to give it to you. Die enigste wat ons verwag julle moet weet is die standaard temperatuur en drukene. Any other pressure or any other temperature that they work at, they will give you a new constant that you have to substitute. Okay, goed. So hierdie het hulle niks gesê nie. So then we assume it is at standard temperature and pressure. Oh, this formula, sorry. N is equal to V over Vn. Use your relationship again and calculate that.